Hello dear students, this is your Guru Dev. So today we'll be discussing about a limiting question, and you can see the question on the whiteboard. It's limit x tends to 0, a to the power x minus x ln a divided by b to the power x minus x ln b to the power 1 by x square. Naturally a and b are positive real constant, and x is a quantity which is tending to 0, so x is becoming very small. So what will be the limiting value of this function when x is becoming very small? Now you see that if I directly substitute the value of x to be 0 in the function, so it will become a to the power 0, that is 1, minus 0 divided by 1, b to the power 0 is 1 minus 0, so this is going to be 1 by 1, that is 1. So the base is tending to 1 and the power is tending to 1 by 0 square, that is a very large quantity. So we can say that this is a perfect example of a limit of the form 1 to the power infinity. Okay, this is called 1 to the power infinity, and whenever a limit is of the model 1 to the power infinity, that means something which is tending to 1, something is trying to reach the value 1 to the power something which is becoming very large, that is infinity. So this kind of form is called an indeterminate form. So 1 to the power infinity is a classical example of an indeterminate form which cannot be directly determined without calculating the limiting value. So to calculate the limiting value of 1 to the power infinity model, we follow a particular concept, that is, we can write down this limit as limit x tends to 0, 1 plus a to the power x minus x ln a divided by b to the power x minus x ln b minus 1 to the power 1 by x square. Okay, so you can see that I have added and subtracted 1 to balance it. So it is becoming limit x tends to 0, 1 plus a to the power x minus b to the power x minus x ln a plus x ln b divided by b to the power x minus x ln b to the power 1 by x square. So now you can see that this whole quantity is now tending to 0 because the numerator is tending to 0 and the denominator is tending to 1, so the whole thing is tending to 0. So if I name this whole thing in this intermediate step to be equal to, suppose, something alpha, which is basically tending to 0, so the model of this limit will become limit x tends to 0, 1 plus alpha to the power 1 by x square can be modified as 1 by alpha into alpha by x square. Okay, I'm writing this in this way as an intermediate step. So you can see that alpha is tending to 0. Okay, so this quantity is tending to 0, so 1 plus something tending to 0 to the power 1 by something tending to 0. So we can easily see that this particular quantity is having a limiting value, which I think all of us know, that is e, because this is tending to 0, alpha is tending to 0, so 1 plus alpha to the power 1 by alpha is going to e. So the limit can be easily written as limit x tends to 0 e to the power alpha by x square. Now you can see that since the base is tending to e, so we'll be interested to take the limiting value of the exponent. So in the next step we can write it as e to the power limit x tends to 0 alpha by x square. Now again, let us come back to our original definition of alpha. So it will become e to the power limit x tends to 0. Let us put the value of alpha, so it is a to the power x minus b to the power x minus x ln a plus x ln b divided by b to the power x minus x ln b into x square. Now when x is very small, we know that the expansion of a to the power x is going to help us here. A to the power x, if you expand, it comes out to be 1 plus x ln a plus x square ln a square by factorial 2 plus the higher powers. This is the expansion of a to the power x, and this quantity plus b to the power x similarly is going to be 1 plus x ln b plus x square ln b square by factorial 2 plus the higher powers minus x ln a. This particular sign in between should be minus, right? Sorry for that. Minus x ln a plus x ln b. This is the numerator, and the whole thing is getting divided by b to the power x. That is again 1 plus x ln b plus x square ln b square by factorial 2 minus x ln b into x square. So you can easily see that some of the terms are getting cancelled out, like this plus 1 and minus 1 cancels out, plus x ln a minus x ln a cancels out, minus x ln b plus x ln b cancels out. So you can see that in the numerator we are having polynomial starting with the power of x to be square. So it is x square into ln a square by factorial 2 and minus ln b square by factorial 2. So in this way it is going to proceed in the numerator, but in the denominator we can see that the x ln b component is getting cancelled out, and on multiplying the denominator is becoming x square. Okay, so this x square is going to get multiplied with 1, so x square into 1, plus we can see that the rest of the term is going to have an higher powers, like x square into x square is going to give you x to the power 4. So we are not really interested about that particular term, because we can see that since in the numerator we have got x squared terms and then we'll be having the higher powers, and here we have got x squared terms and we'll be having the higher powers. And as you know that when x is very small, the higher powers of x will gradually diminish. So compared to x squared in the numerator and denominator, the other terms will become negligibly very small, so that we can easily neglect those particular terms. So effectively neglecting all the other values in the numerator and denominator, we can finally cancel out the effect of x squared in the numerator and denominator to write down the final result to be e to the power limit. So we have already got the limiting value, so it will become e to the power ln a square minus ln b square by 2. Factorial 2 is 2. So it will be nothing but e to the power, I think we can factorize ln a square minus ln b square to give us ln a plus ln b, just to get a compact result, into ln a minus ln b by 2. So it is going to be e to the power ln ab into ln a by b into half, so we can make it much more compact, like we can take this half to be transferred to the power of a by b, so it can be written as e to the power ln ab to the power ln of root a by b, and e to the power ln ab is nothing but ab, so it is ab to the power ln root a by b. So we can leave the answer in this particular format for this limiting question. So the answer will come out to be ab to the power ln root a by b. Thanks a lot for watching this video. You can contact me if you're having any kind of doubt. In the meantime, please subscribe and like us on Facebook. Thank you.